Okay, so this is the 2005 OCR Maths C1 paper. So question 1, 11 to the power minus 2 as a fraction. So 11 to the power minus 2 is the same as 1 over 11 squared, so it's 1 over 121. Evaluate 100 to the power 3 over 2, so that is the same as square root 100 to the power 3, which is 10 to the power 3, which is 1000. Express root 50 plus 6 over root 3 in the form a root 2 plus b root 3. So root 50, the same thing as root 25 times root 2, which is the same as 5 root 2. And then 6 over root 3, we can rationalize it. So 6 over root 3, we can rationalize it. So we can times it by root 3 over root 3, which gets us 6 root 3 over 3. And of course 6 divided by 3 is 2, so you get 2 root 3. So we can write it in the form of 5 root 2 plus 2 root 3. So a equals 5 and b equals 2. Given that 2x squared minus 12x plus p equals q brackets x minus r all squared plus 10 for all values of x, find the constants p, q, and r. So this is just completing the square. So first we take out 2. So 2x squared minus 6x plus p. And then we complete the square. So 2 bracket x minus 3 squared minus, and then 3 squared is 9, so minus 9 plus p. And that can be written as 2x minus 3 squared, and then minus 9 times 2 is 18, so plus p minus 18. So now when we compare, we can say that q equals 2, r equals 3, and p minus 18 equals 10, so p equals 28. The curve y equals 5 square root x is transformed by a stretch of scale factor half parallel to the x-axis. Find the equation of the curve after it's been transformed. So we know that f of x equal 5 square root x. So if it's been transformed by a scale factor of half parallel to the x-axis, that is the same as f of 2x. So it's just 5 square root 2x. So the equation of the curve after it's been transformed is 5 square root 2x. Describe the single transformation which transforms the curve y equals 5 root x to the curve y equals 5 root x minus 3. So first minus 3 is on the outside, so we know that's affecting the y value. And then because it's the y value, we know it's just going to be a translation of 3 in the negative y direction. So translation of 3 in negative y direction. I hope that makes sense. Solve the simultaneous equations. X squared minus 3y plus 11 equals 0, and 2x minus y plus 1 equals 0. So you can say that y equals 2x plus 1, and then we can plug that in. So x squared minus 3, 2x plus 1 plus 11 equals 0. So x squared minus 6x plus 8 equals 0. That can be factorized into x minus 4 times x minus 2 equals 0. So then you get x equals 4 and x equals 2. And then when you plug in 4 into y equals 2x plus 1, you get 4 times 2 plus 1, which is 9. So when x equals 4, y equals 9. And then when x equals 2, it's 2 times 2, which is 4, plus 1, which is 5. So y equals 5. So it's the curve y equals 1 over x. So 1 over x has asymptotes on the y-axis and the x-axis. And it looks something like this. Drawings. Okay, so sketch the curve y equals x times x squared minus 1. And stating the coordinates of the points where it crosses the x-axis. So crosses the x-axis means y equals 0. So we let y equals 0, x squared minus 1. So if y equals 0, then we know that either x equals 0 or x squared minus 1 equals 0. So x squared equals 1, so x has to equal plus or minus 1. And when you expand x times x squared minus 1, you get x cubed minus x. So you know it's going to be an x cubed graph. So it crosses minus 1, the origin, and then 1. So it's going to look something like this. So it's crossing minus 1, 0, 1. Sketch the curve y equals minus square root x. So you should know that y equals square root x looks something like this. Because the minus is on the outside, it's just a reflection in the x-axis. So y equals minus square root x looks something like this, starting at the origin. Calculate the discriminant with minus 2x squared plus 7x plus 3. Okay, so the discriminant is b squared minus 4ac. So in this case, 7 is b, minus 2 is a, and 3 is c. So 7 squared minus 4 times minus 2 times 3, which is the same as 49, plus, because the minus is 24, which equals and take the number of real roots of the equation, minus 2x squared plus 7x plus 3. So 73 is more than 0, so b squared minus 4ac is more than 0, and therefore it has 2 real roots. The quadratic equation 2x squared plus p plus 1x plus a equals 0 has equal roots. Find the possible values of p. So equal roots means it only has one real root. So that means b squared minus 4ac, the discriminant, equals 0. So in this case, b is p plus 1. So p plus 1 squared minus 4 times 2 times 8 equals 0. So you can say that p plus 1 squared equals 64. And then you can say that p plus 1 equals 8, or p plus 1 equals minus 8. So then p equals 7, or p equals minus 9. Find dy dx in the following cases. So y equals a half x to the power 4 minus 3x. Well, this is just the simplest form of differentiation. You can just use the power rule. So you times the coefficient by the power. So 4 times 2 is 2, and then you drop the power by 1. And then you use the same for the minus 3x, which gets you minus 3. And then here, for part 2, well, you can either expand and then use the power rule, or you can use the product rule. I'm going to use the product rule. So u equals 2x squared plus 3. I'm going to say v equals x plus 1. So d over dx equals 4x, and dv over dx. I'm differentiating this value here, which is 1. So therefore I can say dy dx equals, and I use the product rule formula, which is the first, so 2x squared plus 3, times the differentiation of the second, which in this case is just 1, so I can leave it. And then this plus the second, which is x plus 1, here, times the differentiation of the first, which is 4x. So I can expand it and say, expand and simplify. So I can say 2x squared plus 3 plus 4x squared plus 4x. So therefore dy dx equals 6x squared plus 4x plus 3. Okay, so part 3 can just be written as x to the power of a fifth. So then therefore dy dx equals 1/5 x, and a fifth minus 1 is minus 4/5. Okay, so question 8. The length of a rectangular children's playground is 10 meters more than its width. The width of the playground is x meters. The perimeter of the playground is greater than 64 meters. Write down the linear quantity in x. So if we think about the playground as a rectangle, so the width is x meters, so we'll write that as x. And the length is 10 meters more than its width, so 10 plus x and 10 plus x. So perimeter is just adding the length of all these sides. So 10 plus x plus 10 plus x plus x plus x is greater than 64. So then you can say 20 plus 4x is greater than 64. And then that can also be simplified down to 4x is greater than 44 and x is greater than 11. But the question is only 1 marks, so you should be okay by just having this. Okay, so the area of the playground is less than 299 meters squared. Show that x minus 13 times x plus 23 is less than 0. So the area of the playground is going to be x times 10 plus x. Then that is less than 299. So when we expand it, when we expand this, we get x squared plus 10x is greater than 299. We say x squared plus 10x minus 299 is less than 0. Then that can be factorized into x minus 13 times x plus 23. Okay, and then part 3, by solving the inequalities in part 1 and part 2, determine the set possible values of x. So if we solve the inequality here, we get x is less than 13 but more than minus 23. But then in the first one, we said that x has to be more than 11. So therefore, the overall inequality will be x is more than 11 and less than 13. I hope that makes sense, because x has to be more than 11. So therefore, it can't be less than 11. So therefore, the lower bound isn't minus 23. It's going to be 11. So that is your answer. Okay, so 9, part 1. Find the gradient of the curve y equals 2x squared at the point where x equals 3. So y equals 2x squared. So dy over dx is 4x. So dy over dx gives you the gradient of any point on the graph. So where x equals 3, so we plug in x equals 3. So we can say dy over dx equals 4 times 3, which equals 12. The answer here is 12. At a point A on the curve y equals 2x squared, the gradient of the normal is 1/8. Find the coordinates of A. So the gradient of the normal, so 2x squared, and that means the gradient of the normal somewhere is 1/8. So that means the gradient of the point on the curve has to be the negative reciprocal of 1/8. And the negative reciprocal of 1/8 is minus 8. So that means dy over dx has to equal minus 8. So we said dy over dx is 4x, so 4x has to equal minus 8, so x equals minus 2. So find the coordinates of A. So we know the x coordinate is minus 2, then y equals 2x squared, so it equals 2 times minus 2 squared, which is 8. So the coordinates are minus 2, 8. So the points P1, which is 1, y1, and P2, which is 1.01, y2, and the points P3, which is 1.1, y3, all lie on the curve y equals kx squared. The gradient of the chord P1, P3 is 6.3, and the gradient of the chord P1, P2 is 6.03. All of these results suggest that the gradient of the tangent to the curve y equals kx squared at P1. It would suggest that the gradient equals 6. or the gradient approaches 6. Okay, so part 4 is to reduce the value of k, so y equals kx squared. So dy over dx equals 2kx. So we know that x equals 1, it's on the point P1. So dy over dx here equals 2k, and 2k, the gradient is 6, so that means k equals 3. So the points D, E, F have coordinates -2, 0, 0, -1, and 2, 3 respectively. Calculate the gradient of DE. Well, the gradient is y1 minus y2 over x1 minus x2. So we can say this one is x1. So we can say this one is x1, this one is x2, and this one is y1, and this one is y2. So the gradient, which we're just going to call m, is y1, which is 0, minus y2, which is -1, over x1, which is -2, minus x2, which is 0. So I get you -1/2. Calculate the equation of a line 3f parallel to DE, giving the answer in the form ax plus by plus c equals 0. Okay, so parallel, so that suggests that the gradient is going to be -1/2, and then a line through f. So the equation of a line through a point is y minus, I'm still going to call it y1. We can ignore how we called this y1. Y minus y1 over the gradient times x minus x1, where y1 and x1 are the coordinates of the point that the line passes through. So y minus, and the y value is 3, so y minus 3 equals -1/2 times x minus, and the x value is 2. Okay, so here we can expand and simplify. So we say 2y minus 6 equals minus x plus 2, and then we can move them all to one side. So we get x plus 2y minus 8 equals 0. So we can say that a equals 1, b equals 2, and c equals -8. Okay, so by calculating the gradient of EF, show that DEF is a right angle triangle. Okay, so EF, again, the y1 minus y2 over x1 minus x2, so we're going to do -1 minus 3 over 0 minus 2, which is -4 over -2, which is 2. So the gradient of EF equals 2. And we can see that the gradient of EF is the negative reciprocal of the gradient of DE, which can be shown by 2 times -1/2 equals -1. So therefore, DEF must be a right angle triangle. Okay, so part 4, calculate the length DF. So you can think of, you can write them as vectors. So this is F, which is 2, 3. And then to find the distance, you're going to take away the coordinates from each other. So -2, 0. So you get 4, 3. And then you just use Pythagoras theorem, which is 4 squared plus 3. A squared plus b squared equals c squared. So we have square root 4 squared plus 3 squared, which is square root 25, which is 5. Okay, so part 5, use the results of part 3 and part 4 to show that the circle which passes through DE and F has an equation x squared plus y squared minus 3y minus 4 equals 0. Okay, so you know that DEF is a right angle triangle. So if all 3 points of the right angle triangle lie on the circle, then the center of the circle has to be the midpoint of the hypotenuse, which in this example is DF. So the midpoint of DF is -2 plus 2 over 2, comma, and then 0 plus 3 over 2, which is 0, 3 over 2. Okay, so that is the center of the circle. And then you know that the radius equals half the length of the hypotenuse. So we got the length of the hypotenuse to equal 5 earlier. So the radius is just 5 over 2, which is 2.5. So you know the equation of the circle. So the x-coordinate of the center is 0, so it's just x minus 0 squared, plus, you know, the y value of the center is 3 over 2, so it's y minus 3 over 2 squared, equals, and then 2.5 squared. So you're left with x squared plus y squared minus 3y plus 9 over 4 equals 25 over 4. Then you can move 25 over 4 to the other side by subtracting 25 over 4 to both sides. And you're left with x squared minus y squared minus 3y minus 4 equals 0. That was the 2005 OCR C1 past paper. Please leave a like if you found the video helpful, and request any other past papers or A-level past paper questions in the comments down below.